All right, let's check out the example questions for the kites lesson. Example A asks us to find the missing measures in the given kites. If we take a look at what we do know, we know that our top angle here is 130 degrees, and our bottom angle down here is 60 degrees. What we don't know are the two non-vertex angles, left and right. Although we do know that since they're non-vertex angles of a kite, they're equal, so we can make them both be the same variable. And that tells us, since this is a quadrilateral, it's got 360 degrees total, like any other quadrilateral. So we can calculate 130 plus 60 plus 2x's equals 360. Then we can combine our like terms. We have 190 plus 2x's equals 360. Subtract 190 from each side. And we'll have 2x equals, now if I was subtracting 200, I'd have 160. So since I'm subtracting 10 less than that, I have 170. And then divide both sides by 2. Cancel. 17 divided by 2 is 8.5. So 170 divided by 2 would be 85. So x equals 85 degrees. So each of our non-vertex angles then must be 85 degrees. All right, let's take a look at the other one. This one we know that this angle is 94, and it's a non-vertex angle, so its opposite down here must also be 94. And this angle over here on the left is a 90-degree angle based on its markings here. So now we have 90 degrees plus 94 plus 94 plus x, which is the one we don't know, equals 360. So we get 90, 180, 270, and 8. So we have x plus 278 equals 360. So if I was going to subtract 278 from both sides to cancel here, if I were subtracting 280, then I'd have 180, 280, 180, 80. And since I'm subtracting 2 less, I must have 2 more than that, so 82. So x equals 82 degrees. So that tells us that our one missing angle here is an 82-degree angle. All right, let's take a look at example B. Example B says, use the Pythagorean theorem to find the lengths of the sides of the kite. So we're missing this side here. We'll call this one x, and this one over here, we'll call it y. Pythagorean theorem says a squared plus b squared equals c squared, our hypotenuse. So for the upper left-hand side here, side x, we can do 6 squared, which is 36, plus 5 squared, which is 25, equals x squared. Well, 36 and 25 is 50, 61, and that's going to be equal to x squared. So that means that the square root of 61 must be equal to x. Cool. And then for the other side, we have 5 squared. Oops. Probably don't want to actually, drag that color. Let's just draw with it, shall we? We got 5 squared plus 12 squared equals y squared. So we have 25 plus 144 equals y squared. 169. Take the square root of both sides, and we'll have y is the same thing as 13. So this missing side over here is 13 units. All right, let's take a look finally at example C. Example C says, prove that the non-vertex sides of a kite, or angles of a kite, are congruent. I know, nobody likes proofs. This one's pretty easy though. All we need to do to prove that these angles here and here are congruent is to prove that the two triangles top and bottom are congruent, because we already know that if they're corresponding angles and they're congruent triangles, then they're going to be congruent angles. So we just need to prove that the two triangles are the same, and we're almost there because we already have these two sides designated equal and these two sides designated equal. And this side is the same side for both. So we can do side, side, side to prove that they're corresponding triangles, or congruent triangles. So let's take a look at the steps then. Our first statement is the givens. KE is congruent to TE, so that's our two left-hand sides. And KI is congruent to TI, so that's our two right-hand sides. So that's our given. And then EI, the one down the middle, is congruent to itself. That's obviously anything is congruent to itself. And of course with that then, now we have side, 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 as we mentioned just a second ago. And based on side, 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 and congruent parts of congruent triangles are congruent, we know that angle K must be congruent to angle T. So that was a pretty straightforward proof, actually.